Hey, Coach Doubleton here with the third and final lesson in the Lewis dot structures series that we've been doing. This one's on covalent compounds. And with covalent compounds, we talked a little bit about ionic in the last lesson. But with covalent compounds deal with sharing the electrons. So ionic compounds was transferring the electrons. Covalent compounds is sharing the electrons, and we'll show you how that looks with a Lewis structure. Okay, now remember when doing these, I'll review again, but it deals with the valence electrons. So we still have the periodic table here that's attached, but the valence electrons are labeled with this green number right here. Again, the valence electrons are labeled with this green number right here. And going back to nitrogen, that's one that we've been using as the example. Nitrogen, if you go to the top right here, nitrogen has 5 valence electrons. So the first thing you're going to do again is put the dots around the symbols before you show them being shared. So nitrogen right here is already done for you. Nitrogen has 5 valence electrons. So remember to go around the clock. 1, 2, 3, 4, and then 5. And then what we're looking for today are these single electrons. These electrons don't want to be single. They want to pair up with other single electrons from other elements. And that's where the sharing comes into play. So the key word with covalent bonding is the sharing of electrons. The key word with ionic bonding was the transfer of electrons. So again, the first thing you'll do, and I'll do a couple examples, but the first thing you'll do is find out how many valence electrons each element has, and then put that number of dots around the symbol, and then look for the singles. Okay, so let's get started on this. So here's water. Water's a covalent molecule or a molecular compound or a molecule, a water molecule. Water is also covalently bonded. So again, it's a sharing of electrons. Later on, another lesson that we would normally do if we were in school talks about the different types of bonds, either polar or nonpolar. We'll just have you guys show the sharing of electrons on these Lewis structures. Okay. So when you have a compound like this that has more than 2 atoms or more than 2 elements involved, you've got to find the central one. And just to make this simple for you guys, here's a rule to find the central one. We'll stick with the easy method here. The easy method to use is just look at the formula. So the element, when we do these, the element that will be in the center will be the one that is the least number of times in the compound. And it's not always that, but because you guys are away and we're not doing this in class, we'll just keep it that way, where the element that is the least amount in the compound will be in the center. So here's an example. H2O, there's 2 hydrogen and only 1 oxygen. So the one that is the least amount in the compound, because there's only 1 oxygen, that will become the center of the covalent bond or the covalent compound. Okay, so let's put the dots around them. Go back to the periodic table. Oxygen has 6 valence electrons and hydrogen has 1. So I'll put the dots around this one for you. Let's go. And again, oxygen has 6. So go around the clock. 1, 2, 3, 4, 5, and 6. So there's the 6 dots around oxygen, and then hydrogen only has 1. So I'm going to put 1 here and 1 here. Now, what you want to do is you want to, I call it circle the singles. So if there's a single on one element, you want to pair it up with a single on the other element, or in this case, the central one. So circle the singles. I'll show you what I mean by that. And then that pairs them up. They're now a match. So those are being shared. These are the electrons being shared between hydrogen and oxygen. And you can see there's a single here and also a single here. Circle the single. And then those are being shared. This one right here is part of, we call these a pair of electrons. When they have the pairs here, you don't want to do anything with them. So circle the singles. And then what you do after that is these circles actually become the covalent bond. And you want that octet rule again of 8 electrons around each element. Or in hydrogen's case, only 2, because hydrogen only has 1 energy level, and the first energy level can only hold 2. So once you circle them, count them and make sure there's 8. So 1, 2, 3, 4, 5, 6, 7, 8. So oxygen now has 8 electrons being shared between it and hydrogen, and the 2 hydrogens. And hydrogen should have 2 because it only has 1 shell. 1, 2, 1, 2. And then the cleanup, if you just did yours like this for the lesson this week, I would give you the points. But really, you're supposed to clean it up where these circles become the bond. So that's this screen right here. This is a cleaned up version where those circles that we drew become the bond, the covalent bond between hydrogen and oxygen. So I'll go back to the drawing. So we put the dots around them first. Oxygen has 6 dots, hydrogen has 1, and then we circled the singles. That becomes a covalent bond. So you can see there's a circle here and a circle here. That becomes the bond when we clean it up. So here's the cleaned up version. These lines right here equal 2 electrons. Okay, each line represents 2 electrons. So when you count again, there should be 8 around oxygen. 1, 2, 3, 4, 5, 6, 7, 8, because the line represents 2. And that's the octet rule. The lines connecting show the electrons being shared. Hydrogen should have 2 around it because hydrogen only has 1 energy level. So 1, 2, 1, 2, which is correct. Okay, let's try another one. Here's NH3 here. Remember, according to our rule, the one that occurs the most, or the one that occurs the least, is the central one. See if I can highlight that. Okay, the element that occurs the least number of times in the compound is the central one. So going back to NH3 right here. NH3, the N occurs the least because there's 3 H's, there's only 1 N. So nitrogen would be the central one. So let's find out how many dots go around each one. Nitrogen has 5 valence electrons, so 5 dots, and hydrogen still has 1. Let's put the 5 dots around nitrogen. 1, 2, 3, 4, 5. And then the 1 dot around hydrogen. 1, 1, and 1. And then when I draw these, if you put the dot on top of hydrogen each time, that's fine. I try to face the singles to each other. Okay? It's like the valence electrons trying to meet someone on a date. You want to face them. So you don't have to, but I like it. Makes it a little bit easier to circle them if these dots are on the same side or facing each other. Okay, so let's circle the singles. When we circle the singles here, here's a single, here's a single. So I'm going to circle those up. Here's another one. I'm going to circle those up. And here's another one. I'm going to circle those up. And that's the 3 bonds. So I'll show you the cleanup version in just a minute. But you can count around them. Nitrogen should have 8 shared electrons. Hydrogen should have 2. So let's count nitrogens. 1, 2, 3, 4, 5, 6, 7, 8. That reaches the octet rule. Hydrogen should have 2. 1, 2, 1, 2, 1, 2. And here's the cleaned up version. You remember the lines represent 2 valence electrons or 2 electrons. So I'll count again. 1, 2, 3, 4, 5, 6, 7, 8. So there's NH3 right there. And there's actually names for these shapes that they form. But again, because we're not in school right now, that would be another lesson that we would do. So if you, when you do the actual work, the Jamboard that we share with you, if you just left it like this, I would still give you points. I would assume that you understood it. If you want to do the cleaned up version, some kids actually like to do the cleaned up version before or instead of circling the singles. Okay, a couple more. There's different types of bonds too. The 2 that I've showed you so far are single bonds. These are the single bonds right here. There's also double and triple bonds. So here's an example of a double bond, okay, CO2. Remember when we do this, the one that occurs the least, our simple rule, the one that occurs the least is going to go in the center. So I'm going to move these over. Put carbon in the center and the 2 oxygens outside of it. Okay, and then we're going to put the dots around it. Let's go figure out how many dots each one has. Carbon has 4 valence electrons, so 4 dots, and oxygen has 6. Again, carbon right here has 4 valence electrons. Oxygen has 6 valence electrons. Okay, so let's put the dots around it. Carbon 4, 1, 2, 3, 4. And oxygen 6, 1, 2, 3, 4, 5. And because I want them to face each other, I'm going to put the 6th one here and then 6 over here. 1, 2, 3, 4. Go around the clock. 5, 6. So remember, these are paired. These are pairs right here. These are already together. You want to circle the singles now. Pair them up with a single from another element. So here's a single. I'm going to circle this. Here's the single. I'm going to circle this. Pair them up. Go on a date. Single here and single here. Let's pair them up for the date. And single here and single here. And let's pair them up for the date. And again, if you only did this, put the dots around it and circled the singles, I would give you the points for the lesson this week. Really what you want to do though is these circles become bonds between carbon and oxygen. So there's 2 bonds here between them and there's 2 bonds here. So let's look up the cleanup version. And here's the cleaned up version. Again, I'll flip back. These circles that you drew become the bond that holds these together. Okay, again, the circles become the bonds. So let's count around each one. They should have 8 around each one. 1, 2, 3, 4, 5, 6, 7, 8 around carbon. That's good. Oxygen, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And these are double bonds. Double bonds are shorter and stronger than single bonds. Okay. And then one more, I'll show you a triple bond. Here's a triple bond. Nitrogen has 5 valence electrons. And if you forget how many valence electrons they have, you can go back to that periodic table. Let's put 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And if there's less than 3 elements, you don't have to worry about a central one. This one only has 2. So just 2 elements right there on that page. Let's circle the singles. Okay. So this gets a little messy when you circle the singles because you have to go over the elements, but remember the circles represent the bonds. So here's one, match them up, pair them up, go on a little date. Let's circle these. Oh, good. Those are paired up, and let's circle these. Circle the singles, make them a match. Okay, and remember, these circles now become the bond, and you'll see the cleaned up version on the next page. So here's the cleaned up version. There were 3 circles connecting them. Those become the bonds that hold them together, and they should have 8 around each one. So I'm just showing you where the 8 are. 1, 2, 3, 4, 5, 6, 7, 8. And then the same thing with this one, the octet rule. Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right, and then the work that you guys will do are these pages right here. This one's actually already done for you. You just have to clean it up, show what the cleaned up version will look like. And then right here, N2, and then B and F. And then this page right here. So you just have 1, 2, 3, 4, 5, and then an easy 6th one right here. So 6 problems to do this week. And then remember, if you need extra help, I'll also share a YouTube video that explains this. My YouTube video, then another one also. And don't forget, you can email me. You can go to the Wakelet also. That has a lot of different videos on it that you can look at. But from what you guys have been doing, I think you guys have been doing a pretty good job in getting this. So I'll share these problems separately with you from this video right here. And you just have to start doing the problems. I'll actually put that on here. Okay. You'll just start right here where it says the student problems and do the next couple of pages. And don't forget, you can join the office hours if you have questions or if you just want to stop in and say hi. All right, so that's it. That's your lesson on covalent bonding for the week. Let me know if you have any questions.